Yes. So will you share slides and then
Okay.
I will share my the latest theme.
Okay, right. There we go. All right, so my name is Edoardo Vacchi. I'm a Red Hat senior software engineer. I work on Kogito, and there's with me Mario.
Hi, my name is Mario Fusco. I also work for Red Hat. I'm one of the co-founder together with Edoardo and other engineers of the Kogito project. I'm the project lead of Drules, which is the rule engine of Red Hat and one of the key component of Kogito, of which we will speak about later. And I'm also a Java champion. Okay, so this is the agenda for today. We will give a look more in general at some key cloud concept and how they fit with business automation, what it means to set up a business automation project in the cloud. So after that, we will give a deeper look to the technologies that we want to present today. So, as I said, we have a cloud-ready business automation project, which named Kogito, but it is based on two well-established engine. One of them is Drules, the rule engine that I mentioned it before, and the other is JBPM. And we also have a component for a new standard that is called the DMN that we'll also demonstrate later. And the other thing that we want to show is also how this is also integrated with the Quarkus, the new Red Hat framework, and how this all aggregation of project or component can make sense in one single project deployed on the cloud. So I will leave the stage to Edoardo for this first part of the talk.
All right, thank you, Mario. So today we're going to talk about business automation, and a little bit more in general. At the beginning, we will talk about cloud native development. The reason why we're talking about this is that the word around us has changed. The thing that we used to do, now we do in a different way. There are different usage patterns for application. There are different deployment techniques for our applications, and we are developing application in a way that makes better use of machine and cluster resources, because we used to develop application and deploy them onto large servers with a lot of memory, with a lot of CPU. Today, things have been changing because a lot of people no longer own their infrastructure. They're using services that host their infrastructure, and infrastructure is built usually depending on the usage you make of it. So that's the reason why we want to make a better usage of that, because we want to spend less, right? Now, a couple of funny slides. This is a Twitter account. So if you heard about the cloud and modern application development, you have heard about containers. So here we're joking about putting your app on the JVM, put your JVM inside a container, put your container on VM, put your VM in the cloud. Please get the code as far from me as possible, says the said server. So this is just a funny tweet just to say that the development and the way we deploy application has changed. So you've heard about containers, we've heard about the cloud. And the idea here is that you no longer own your infrastructure, but you deploy to the cloud. And as you probably have heard about, the cloud is nothing more than someone else's computer. So even though even though you don't own it, you have to know that there is a computer there, and it has limited resources, and you have to be attentive to the way you use those resources. Now, in particular, we talk about application density. What does this mean? So, when you have some server, the server may be large or maybe small, but there's a finite amount of space that you can use to host your applications. So traditionally, Java application in the server space have been pretty big, pretty large, and they used a lot of memory. And that was affordable for us because the application did a lot of different things all together. The application was more monolithic, so to speak. And it was lower to boot up, and that was fine because once you booted it up, you didn't really had to reboot it a lot of time in a while. But at the same time, today, as we said, things have changed. Our application tend to be smaller and to do less things, and the way we do more complicated things by orchestrating these applications. That's why a lot of people. That's one of the reasons why a lot of people have been choosing different runtimes and different programming languages with a different approach to deployment and development, such as Go, for instance, or Node.js, and or there's Python, Ruby, and all those kind of different runtimes and languages. The key thing for all of these is that sometimes they have a tinier footprint, and you can cram more of those in the same server space. For instance, Go goes even as far as being a native language. So you compile it into native, so it's tinier, and it has a smaller footprint. And yet it has people loves it because it's a sort of lower level language in that it compiles to native, but it's still productive as a very high level language. So it is still high level even though it compiles to native. And what does put us as Java developers? Is it all lost? I mean, can a Java developers be can they be cloud native, so to speak? So the thing is, actually, Java application can be developed in a way that's more friendly to the cloud. And here in this picture, I show native Java. And I don't mean it just as compiled to binary, compiled to native, but in general, I mean it as cloud native Java. The thing is, the Java runtime is not necessarily heavy. It can be tuned to be made smaller, and Java wasn't even born as a language that had to be run on a fat, huge server. It was meant originally for embedded platforms, and JDK can be tuned so that it can be smaller. The problem is the frameworks that we've been using for quite a while are so convenient because they come with a lot of features and they do a lot of processing at runtime. This makes them very convenient to use, very easy to understand for developers from certain points of view. But at the same time, they do a lot of stuff at the boot time, making the boot slower. And the fact that they do a lot of different things at runtime makes them also make them bigger in terms of memory consumption and CPU. So with Cloud Native Java, I mean not only being able to compile Java to binary, which is possible by choosing some particular runtimes, more modern, more non-traditional, if you will, runtimes, but it's also about being able to understand what's running on what is necessary to do at runtime and what is necessary to do at build time. And there are a lot of runtimes today. Well, a lot. There are a few runtimes today that allow you to do so. And I want to mention just a couple. Micronaut probably is one of the most famous. Of course, Quarkus, which we're going to talk about, especially Mario will talk more about Quarkus later during this presentation. So nothing lost, and I am your density. So we can cram more application in the same space if we choose the right framework. If we pick the right framework. So this can be thought of it's a solved problem. More about traditional versus modern. We used to develop application on application servers. Application servers, I guess you're already familiar with what they are. If you aren't, they're Java applications that where you deploy multiple applications at the same time. So they're Java servers that expose Java as a web server usually, and you can deploy on it many different Java applications, usually packaged as a WAR. And these application servers comes with a lot of services that can be used by your application. This is not so different from what happens in the modern way to develop application, in the modern approach to application development. It's just that the application server is not Java specific, and it is the role it's played by Kubernetes or OpenShift, and in general by container orchestrator. The role that was played by WARs is now played by containers. So you package your application in a container, and then you can use services that are provided by the platform for consuming messages, for storing data, to expose metrics. You can choose your runtime, and in this case, we're showing here Spring Boot or Quarkus. But if you're not developing using Java, that's the real power probably of the container orchestration approach, is that inside your container you can basically deploy anything, and you have a truly polyglot ecosystem of microservices that can coexist all together in the same space. And of course, the orchestrator does much more than that. Besides orchestrating containers, it's also able to manage their life cycle and deploy them on different machines. So it's no longer one application server on a single machine that communicate possibly with other machines, but it's a cluster of machines where you do not really care anymore whether your application is running on one or another, because it will be the cluster manager, the container orchestrator, to understand where your application can fit better, deploy it there, and then decide, even in some cases, to scale it up and down depending on the number of requests that are coming from outside. So it's a whole different world, but in a certain way, it's also kind of the same thing. I mean, it's just in a different framework, just in a different setting, but the concept is very similar. But it's not just about the way we think about our application and the way we write them. It's also about a paradigm shift of mentality, about paradigm shift in culture. In this picture, we see the cloud includes different ways to develop your application, as in developing them, as we said, as services that provide smaller features instead of being a fat and big monolith that does one thing. And there's the DevOps culture. There's CI/CD. Your application will be delivered by very quickly and very often by having a pipeline that manages the building and the deployment of your software. And of course, there's containers for packaging. Now, today I want to talk a little bit about serverless, which is one of the most modern, although experimental features in Kogito. It's something that we've been working on, but I don't want to just talk about Kogito. We will talk about it because Kogito provides one possible implementation, but we will talk about in general serverless and serverless workflow. So what's serverless about? As I was saying before, the idea here about modern development is that you do not really care. You do smaller applications that do one task and you deploy them somewhere in the cloud. You no longer care or know or need to know where your application is being deployed. It would be the platform to decide where this will be delivered, and it will even manage their life cycle. The platform will decide if the application has to be restarted, and even in some cases if it has to be killed and has to be stay disabled. To the extent where some application can be so tiny that we call them functions. In this case, so this is what serverless is about. The idea that you don't even care if your application is running or not, because it will be the platform to decide how to scale it up and down. And your application is so tiny that does one little task at a time, and that's why it can be easily scaled up and down. And yeah, and also the fact that it's tiny makes it possible to build it in a more finer grained way, and so you will spend less. Okay, so that's the idea with serverless. So since now our services, our very tiny services, are now called functions, there comes another requirement, another issue. Your application is now made not only of different services, but services that are so tiny that in order to describe a complete flow, you have to stitch them together. This is something that we already did with microservices, but with function it's even more important because functions are so much smaller. And that's why we need what we call function orchestration, which is represented here as a diagram. You have a function F, which is really, a mathematical name, a mathematically inspired name, but it really means a tiny service. You have a function F that does something, and in order to complete all the processing, it passes the data that comes from outside it that's been processed into G. And G is another service, another function that will process the data again and further refine it and then return the result. And of course, the flows of the data can become very complicated. And that's why you want to have a way to describe it in an easy way, in an easy to visualize way. And you also want to be able not only to describe them, but to deploy the description and be managed automatically by your platform. And that's why we talk about workflows. And that's also where business automation comes into play. The term workflow or process, it's a term that is very familiar to everyone that's been working and using business automation in their job. So business automation is all about automating businesses, and among the capabilities of business automation, there's workflows, which are a way to describe the flow of a document, the flow of information in general inside a business process. So businesses are all about processes. When you start to do something like booking a flight or hiring a new employee, all of these different processes are described as a flow, can be described as a flow of information, and that's why we use particular pieces of software that we call workflows to describe these flows. Now, a workflow may be sequential or parallel. But and that's also important because we want to orchestrate our application in a parallel or sequential way, and we will see this how this is important. Now, as I said, let's put these two concepts together: serverless workflows. So, as I said, there are functions, there are workflows. How do you orchestrate functions in a serverless environment? Every vendor, and there are a number of different vendors, you name it, AWS, Google, or IBM, even Oracle, they all provide a platform for running serverless applications. And every single vendor has come up with their own standards to describe how serverless workflows should work. That's why there is this ongoing work on a specification that's vendor neutral and portable across different implementations. With this specification, you can basically describe a workflow in a way that is not dependent on the specific vendor that you've chosen, and you can port it in an understanding regardless of the implementation. The specification describes a JSON file format or YAML file format. You can choose whatever serialization format you want. JSON might be better for machine consumption, while YAML may be better for writing by a human being. But YAML is sort of a superset of JSON, so they're compatible. The idea is that you can have different implementation of the serverless workflow specifications and have it run on any of the providers, including OpenShift and Kubernetes, any of these providers, any of these platforms, without having to do much fiddling. The specification at its core is very simple. It has data header, and then there's three main sections: function sections, events section, and states section, because the workflow is composed by states. It can respond to events, and the function are the manipulation of the data. Here's an example, very simple hello world. So very familiar. The process starts, the workflow starts and ends. And in the hello state, a message is composed and returned. And then by flowing to the end of the process, the message is returned and the message is hello world. Another example, a little more complicated, could be this one. In this example here, we have the same hello world, but instead of just returning a message, an external service, a function is called, and the function returns the actual message. The function actually takes the input from the payload of the message that comes, the payload of the request that comes from outside into the start node. It flows from the greet task into the action node where the function is actually executed. We returns a message. The message comes back to the greeting task and then goes to the end of the process where the message is returned. Now, this is are two very simple examples. And of course, if the workflow specification reduced to this, it will be pretty useless. And that's why you can also, free your imagination and do as much complicated flows as you want. And that's the real power here. As you can see on this diagram, you have a choice. It could be that a decision is denied or approved. And at the top right, you can see that there's an external service that's called, that responds asynchronously using the little cloud icon, which represents an event, so-called cloud event, which is another specification for describing events in the cloud. And there's another example here with no external services here, no messages, but just to show you that a workflow can be as complicated as you want. As you can see here, there's loops. The state can get back to a previous state if there's some error, and so on and so forth. All of these examples you can find at the serverlessworkflow.io website, where there are examples and the full specification. Now, a couple of words about Knative. I mentioned a couple of times that in a serverless framework, in a serverless platform, the idea is that your application can scale up and scale down automatically depending on the data that's coming from outside. How do you achieve this? Well, every vendor has their own implementation, but there's also standard implementation for Kubernetes that is called Knative. Knative has two main components, the serving component and the eventing component. And the serving component, basically, it's the component that manages the lifecycle of your application, and it can scale it down even to 0 when there are no incoming requests for it. The magic here is that if there are incoming requests, then the application will be basically created and leave their dormant state and made available for responding to the incoming request. And the eventing instead is dealing with actual events. So not only serving HTTP requests, but also messages. Similarly, this provides infrastructure to respond to events. And similarly, it deals with the way these events are delivered to applications and then can be scaled down and up, depending on the number of requests. And that's where we talk about Kogito. So let me do a very small and brief introduction, and then Mario will go more into the details of what Kogito is. The pronunciation comes from the Latin motto "Cogito ergo sum," I think, therefore I exist. And the pronunciation, the canonical pronunciation, if you will, it's cogito for us. But actually, since it comes from Latin, a lot of people pronounce it differently depending on how they read it, depending on how they know to read Latin and whatever. Don't worry, nobody in the team actually gets it right, so it's fine. And cogito ergo automate, so business automation. And why cogito with a K? Well, of course, because Kubernetes and Knative, but also because the K stands for knowledge. And speaking about knowledge, the icon, the logo for Kogito is this Viking, because it is not a pirate. And it could be mistaken for Mario, actually, because of the beard and the and the mustache. And we try to make Mario wear an helmet, actually. But it's actually a Viking. It's Odin, the Norse god who sacrificed his eye for the gift of knowledge. So what is Cogito? Besides being a Latin motto and having something to do with knowledge, Cogito is the way we reimagine our state-of-the-art business automation platform by making it cloud native. We provide a plethora of different features, of different capabilities. We support rules and decisions and processes and case, and of course, and this is the new kid on the block, and that's why I really wanted to talk to you about it, it's serverless workflow. Under the covers, it's still using our good old engines, but rethought, reimagined, and fine-tuned to make them work in the cloud-native setting at the best they can. We embrace a compile time, a code generation oriented approach to make it possible to run these applications faster, and also to make them lighter and in such a way that can actually be scaled up and down depending on incoming requests, making them even a perfect target for serverless workflows. And I mean workflows here as in serverless platforms. And yeah, and there's different ways we provide support, and Mario will go more into the details of that. The way you deploy application canonically using our operator that you can get from Operator Hub. It runs both on OpenShift and vanilla Kubernetes. And by installing the operator, then you can run your application using Kogito, which, by the way, support both Quarkus and Spring Boot, because the standard is Spring Boot after all. And it will deploy your application on your Kubernetes cluster without any effort on your side. It will manage the life cycle of your application and will also deploy possibly the required services that your application needs. And there's a CLI, because everybody has a cool CLI. And from the CLI, you can create a new application, point it to a Git repository, and have it deploy your application from scratch by building it and creating the container, delivering to the container orchestration platform, making it run. And of course, if you choose Quarkus as your runtime, you can also have the full power of native compilation, which of course we support. But before we get to that, let's wrap up this section, this first part of the discussion by talking a little bit about serverless workflow, again, with a complete example from the beginning to the end, and then we will have a small demo of it running on Knative. This is the workflow. I don't want you to read it completely because we will get to it, to the single parts of it, but it fits in a slide, so it's not big, it's not complicated, and it doesn't do much. So it takes as an input this JSON payload with a name and a language of your choice, and depending on the language that's been chosen, it will greet this person using the language that they've chosen. The language may be Spanish or English, and English is also the default choice. So if you do not use English, it will fall back to English, and then it will greet this person. So at the bottom, on the top side, you can see the nodes. So you can see that there's this choose on language node, and then there are two edges. And there's a condition on these edges. Depending on the condition, if it's equal to Spanish or it's equal to English or it doesn't fall in any of those two cases, we will go into a task or the other. Then, depending on the task that we have chosen, a different message will be returned. And then the last node will compose the message that's been returned with the name of the person that's been given as an input and return the name. So it will return the greeting. So it's pretty simple. Okay, so sit tight for the demo. This demo is running on my laptop, so it's pretty slow. So don't be scared about that. Let's watch it together. It's a couple of seconds. So on the top, you won't see any output right now because there's no application running. As soon as the bottom side hits enter, in the bottom side will come a request. And as you can see, a request has been delivered to the cluster. And now at the top, you can see that actually a container has been spun up to respond to the message. Let's see it again because it was very fast. So as you can see here, yeah, there's no output at the top, but then the message from the request comes in, and here it is. There is now output at the top because the container is spun up to respond to requests, and it's as much as you send more requests, you will see that more containers and the counter will increment. At the beginning it's 0, then it responds, it becomes 1, then as more requests come, it becomes 2, and that's how it responds to the incoming request. And as you see, it's pretty fast. And that's the magic of Knative serving. All right, that was all I got. So I can leave the stage to Mario, and thanks for staying with me. And please stay again and stay a little bit more with Mario, who will go really into the guts and the details of how Kogito works.
Okay, so maybe Edoardo, I can share my slides. Otherwise, I will have to next. Yeah, so stop your sharing, and I will try. Okay. Okay. Can you see my slides? Okay, great. Yes. So yeah, so Edoardo mostly introducing the framework on which we are developing our software, and mostly how we are deploying it. Okay, but what is this stuff? Okay, so Kogito is this new cloud native business automation project, but is based on some well-established, let's say, old project, battle-tested projects like Drules and JPPM. Okay, so mainly when we speak about business automation, we speak about two things: the processes, which are a process is a set of activity that has to be performed sequentially, or some of them in parallel, to achieve one or more goal. So we create a workflow made of these single specific activities, and how to are connected to each other, and this create a process. Okay, and our process engine is JBPM traditionally. The other component is a rule engine. The historical rule engine of Red Hat is Drules, and it encapsulates, it allows user to describe the business logic in a way that is closer to the stakeholder of the business itself. So what I'm saying is that when you normally write your business logic, you write it in Java, let's say, or in your host language, okay? Meaning that your business logic is embedded, is mixed with the architectural logic, with the architectural code. They are strongly entangled. They are strongly related to each other, and this is probably wrong for a few reasons. First of all, because it's not understandable for by a business user. A business user cannot read the business logic developed in Java or in any other programming language and at least validate it. Okay, and most of all, and the other aspect is that normally or in some environment, they have a totally different life cycle. The business logic, for example, for marketing purposes, or for or to follow a change in a law, can change quite quickly and quite often, while your architecture is quite well established, and hopefully is made to be run as it is for years. So this means that it is in our interest to decouple the architectural part of your program with this with the part that implement the business logic. Okay, and how you normally do this with rule engine is that you write in a your business logic in a when-then form, meaning that you saying that when some condition are met in your domain object, then you take some action. Okay, and by doing this, again, I already more or less discussed the advantages of this approach, but mainly writing rules, business rules in this way is easier to understand for the stakeholder, is easier to maintain, it's easier to make it evolve and change, because again, the business logic is decoupled and written in a more readable language than the programming language you normally use for your architectural code. Rules in nature are more modular. You can compose them. Again, I already speak about the clear separation of business logic from the rest of your system. And okay, and the rules also offers you the possibility to do complex event processing, meaning that you can see your the fact that populates your rules session as event, and then reason on the timing, on the temporal delay among them. Okay, so but I just wanted to give you a rough idea of how this thing work. internally. Actually, this is really a high level overview, but mainly you have the rule engine works on two set of things. One of the rules, so the set of your rule implementing your business logic, and the other is the working memory. So the fact, the events, if you are doing complex event processing, that you send to the engine, and the engine used to evaluate the rules against them. So what it happens is that the core of the engine is the pattern matching engine that put these two things together in an efficient way. So it tries to find matches between a specific rule and a specific set of facts. And when it finds it creates what we call an activation. So an activation is a tuple made by the set of facts that activated that rule, that made the conditions of the rule true, together with the rule itself. So the pattern matching engine creates a list of this activation. The activation are put in the agenda. The agenda is an internal algorithm pluggable strategy that prioritize the different activation, and then the activation are sent one by one to the execution engine, which basically execute the action that are described in the then part of the rule. So yeah, I wanted to give you a better idea of this with a simple rule set. You see 5 rules here. Each of them have the when and the then part. So in particular, in the first rule that I highlighted there, I'm saying that in case there is a fire in a given room and the sprinkler is not on, then the rules say, okay, activate the sprinkler and okay, print an alert message. The other big component of Druce, as I said, is JBPM, is our workflow engine. As I said, the biggest, in reality, the totality of your business logic can be expressed either with rules or with a process or with a combination of the two things. So with these two items, you can really express all your business logic, and JBPM is based on some standard, which are BPM2, and it is also integrated with another standard that I will mention later with the latest demo, which is called the DMN, and of course it's also integrated with the rule engine, so with the Druce rule language that I showed just before. So yeah, JBPM is based on the definition of our workflow is based more on a visual language, let's say. So we have a simple process to take all the necessary steps to book a travel. So you check if you have or not to apply for a visa, and in case you do, then in parallel, when your visa is approved, then in parallel you can look for an hotel and a flight, and when everything is confirmed, you are ready to travel. And this is the very simple workflow that you probably follow every time you travel. Well, not in the last year or so for obvious reasons, but this is unfortunate. We are not traveling that much, but we will be back on the road soon, I hope. Okay. Edoardo already introduced what Kogito is. I will go fast on this section, but as I said, we wanted Kogito to be focused on the business domain of the user. So the user of Kogito don't have to focus that much on the infrastructure. We don't want to have leaky abstraction, but we really want to focus on the. We really want the users of Kogito to be able to focus on their business domain, on their business rule, and or on their internal workflows. We have we are trying to make the life of Cogito user simple. So we are creating our own tooling. I will give a demo of this as well. Most of the time we do code generation for you, meaning that you can just write your rule or create your workflow in a visual way, or use the DMN standard, for instance, and we, in most cases, create the biggest part of the code for you. One of the other strength of Cogito is that we try to develop a very good integration with Quarkus that I will discuss quickly later. This gives you more developer joy, as the Quarkus developer said, meaning that you will have a few tools like the library load that can make your life easier and your development cycle much faster. And yeah, also Edoardo already discussed this in deep. So we try to make a platform that is cloud ready, so it's integrated with all the technologies that Edoardo mentioned before. A few words also about Quarkus. Maybe you have heard of it. It's a new framework for writing Java application developed by Red Hat. We are not forcing users to use Quarkus, as Edoardo anticipated before. Cogito can be used also with Spring Boot, for instance, but we strongly suggest to give Quarkus a look because you can have some goodies. Let's see what Quarkus can give you. So one very important thing, especially in the function as a service scenario, is that Quarkus allows you to compile your Java application, create a native image out of your Java application. This means that this is based. This feature is based on what offered by GraalVM, and this allows you to have a very smaller footprint, so to increase that application density mentioned by Edoardo, and to have multiple services running on the same server on the same machine. And the other thing that you will see is that it gives you this hot reload feature that is very nice. And Quarkus is based on tons of the standard that you already know. So you have JPA, you have CDI, logging, the micro profile, of course, servlet, and all the technology that you already know. And there are a lot of extensions for Quarkus that allows you to quickly use this technology. So you have the extension for Camel, for Vertex, of course, for Cogito, for Prometheus, and many more. In a word, why Quarkus? Sorry, because again, Quarkus allows you to have a lower memory usage, so to increase that application density, that allows us also to reduce our costs. and it offers you faster startup, is Kubernetes native, it has auto-reload that I will show in a bit. Okay, yeah. So all the Quarkus extension has the possibility to use to leverage the Quarkus auto-reload. What does it mean? It means that when you are in development mode, you start Quarkus, you modify your code in general. Typically, you modify your Java class, and then you don't have to restart the server. The Java class is ingested automatically by Quarkus, and you can interoperate with your server with the changes already in place. But this is not limited just to Java classes. We also wanted to offer, of course, this possibility also for Kogito artifacts. This means that you can have auto-reload on a Druze rule base or a JPPM workflow. You can, meaning that you can start your Quarkus in development mode, and then make experiment, let's say, change the rule or change a workflow, and immediately see the effect of these changes. Okay, a few words about the typical architecture of a Cogito application in the cloud. Okay, this is just a typical situation. It doesn't have like this. It can be more simple, it can be more complex, but typically what you have is that you have multiple Cogito services, again running a rule set on a side, or a DMN definition on the other, or a project or a JPPM process that probably coordinates all these things. And then you can optionally persist this stuff. I put in Finispan there. Actually, it could be any let's say cloud ready database. So we have, for instance, integration with MongoDB if you want. And then typically what you do to connect more services is make them speak through Kafka messages. And another very typical thing is that you can monitor your service. Let's say check if they are working well, if how many requests they are service with in a visual way by integrating Prometheus and Grafana. And of course, everything, all this stuff can be scaled up and down eventually to zero with the operator that Edoardo mentioned before. Okay, so this is a very simple example that I wanted to give with a Druze rule. So what I'm doing here is that I'm evaluating the loan application. I'm saying that if an application, the age of the applicant is greater or equal to 20, and it has 1,000 euro now deposit, and the amount of the the requested loan is lower than prefixed maximum amount, then we can approve the application. Okay, and so we have a rule. Of course, typically you have many of them. I'm just putting here a business rule to to define when I want to approve a loan. Okay, and if my business rule changes, I require the age to be greater than 25 instead of 20. This is not mixed with my code again. It's in this rule, and you can immediately change it. Okay, and then the other thing is that the way you interact with this rule set is Okay, by providing, of course, in input set the applications to be evaluated, and then you have a query that in this case returns you the only the applications that are approved. Okay, and if you do this, we we can automatically generate a REST endpoint consuming this rule set for you, meaning that you don't have to write this code. We again automatically generate it for you, and this means that out of the box you have a REST endpoint to which you can pass a list of loans application in JSON, for instance, and be returned by using this query, for instance, in this case, with only the loan that have been approved. And of course, you can have multiple query, and for each of these query, you will have a REST endpoint exposed. So I discussed about rules. I discussed about process. There's a third leg of Kogito, which is the DMN. DMN is a new standard defined by the OMG. It is actually for decision what BPMN is for processes. So it is a complement for analytics and for artificial intelligence models in an explainable way. They are allowed to define and expose decision, but not in a let's say black box way as normally a neural network does, but in a clear way the decisions are modeled by the business expert. And the other important thing of DMN is that it is stateless in nature, and this makes it a perfect fit for a serverless architecture. You can see the DMN, or you can see the DMN how we are proposing it as a function. You can invoke it as a function and combine the decision provided by the specific DMN decision with other function, with other rules or processes or artifacts that are typical of your business environment. And DMN is also visual notation. Basically, it is made of a few component, few nodes. You have an input node when more than one input node when you provide the input to be evaluated by the decision. You can have one or more decision node where the decision is made, and this decision node also are defined typically in a visual way, for instance, by using a decision table. Let me change my screen sharing and show you an example, a practical example of this. Okay. Okay, so can you see my screen? Is it readable, Edoardo? Is it readable? Okay, so I have a very simple decision here. This decision has two inputs: the driver that has a driving license, of course, and driving license as a set of available points that you can use until the driving license is suspended. And then you have the violation that comes with a given amount that causes, of course, a fine that can be both a money amount of fine plus some points to be added to your driving license. Okay, and then you can define these different type of fines or violations in different ways. So if I have a speed violation between 10 and 30 kilometers, I will have 500 euro of fine, plus 3 points more on my driving license, and then you can read the other violation that I defined here. Okay, and this is the first decision. So I'm defining in a visual way what happens when you do a violation while driving. Okay, and then I have one further decision that is also the consequence of the fine itself. So I need to decide if your driving license has to be suspended or not. Okay, so and the simple rule here says that if the total points, which are the sum of your current driving license points plus the points of the current fine, are greater than 20, then your driving license will be suspended. Otherwise, it won't. Okay, and that's all. So this is very simple. I can define my business logic in DMN, or as I said before, with a set of rules in more complex situation, and then I'm done. I can put this stuff somewhere on the cloud, and magically it becomes a function that I can invoke how many times as I want. But before doing this, I want to, let's say, fine tune, keep working on this thing, maybe in an iterative way. This is very common if you think about it when you work with business stakeholder. Let me check what happens if I change this, and you want to do this quickly. Okay, so this example is using our Quarkus extension, meaning that it is integrated with Quarkus. I can launch it in dev mode with this Maven plugin that allows me, with the Quarkus Maven plugin that allows me to launch this example in development mode. Okay, it does some stuff. In our cases, it is also doing the scaffolding of the code generation of the code corresponding to this decision that I defined. Okay, and if you look at it, when you do this, you have it also open the backboard by default, so you can also debug your code. It takes quite a 9 seconds to start, but now it's up and I can try it. So here I'm sending a JSON to this. I have a driver with 16 points on his license, and I have a violation of 20 kilometers per hour speed, and I want to see what happens. Okay, and the outcome of this is that I have 3 more points on my driving license, and I'm fined of 500 euros. But the sum is 3 plus 16 is 19, is lesser than 20. So my driving license will not be suspended. Okay. But I can change this logic if I want. So I can say that okay, when I do a speed violation between 10 and 30 kilometers per hour, now I want to give 5 points, no longer 3, 5. I can save this, and then I can try to rerun. And as you can see, Quarkus perform a not reload. I didn't stop anything. The server is running as usual. but my changed business logic has been applied on the fly. So this time, the violation that I made comes with 5 points, meaning that now I have 21 points in total on my license, and this means that the license has to be suspended. Okay. So this is the power of hot reload. This is what Quarkus developer call developer joy. You can experiment with your stuff, you can change your code, and you don't have to shut down your server and then restart it. Everything is done under the hood for you. The one last thing that I wanted to show is that, okay, I showed you the hot reload feature. The other thing that I wanted to show is that Quarkus also allows you, as I said, to create a native image of your project. Sorry, one thing more. As I said, as you can see, I'm invoking a REST endpoint here. As I said, this REST endpoint is automatically generated for you. You don't have to write one single line of code. This stuff is generated for you, and you have this REST endpoint exposed by the code that we generate. You are not writing a single line of code. Let's say, okay, Quarkus also allow you to create a native image of your application. It takes a few minutes to create it. I created it before giving the talk, but what are the advantages of this? Again, it is no longer a full-fledged Java virtual machine that is started. It is a native executable that I created on my machine, and when I launch it, remember it took 9 seconds to start. Now it's super fast. Well, it is taking 49 milliseconds. I have seen faster execution. Sometimes you see now it's just 27 milliseconds. I mean, it is up in a few milliseconds, and this makes it a perfect fit for a function as a service environment, because your service can eventually scale to 0. You don't have any machine at all serving your decision as a function in this case. But when a request comes, you can immediately set up, create a server, serving it, evaluating the decision, and eventually shut down the server again. Okay, and of course, I can send exactly the same. I can invoke exactly the same endpoint as before, and okay, this time is not suspending my driving license because I compiled it with the former definition of the DMN decision model. Okay, let me go back to slides. But this is basically all I have. Okay. So I guess this is basically all we have. So let us know if there are questions. I don't know if people are allowed to write question in the chat. Probably I don't see any question, but let me know. And otherwise, feel free, if you are interested to this stuff, feel free to, of course, visit our website, and if you want to get in touch with us, we have a Zurich channel. So also, if you experiment with our stuff, if you have bugs to report, so question to ask, or suggestion to improve our stuff, please feel free to get in touch. And this is all. Thank you.
Hi, Mario and Edoardo. Thanks for the presentation. I have one question for you. I saw examples with YAML definitions, and I remember that there was or still is a Fluent API in the BPM where you can define your process by writing Java code. Are there any plans to allow process definitions in YAML or to keep supporting the Fluent API? Asking this as I find that especially useful for tests where the processes are relatively small and easy to modify.
I can take this question. No, actually, the Fluent ESL is the code that is being generated when you define BPM using the standard graphical interface. So BPMN files are now in Kogito being translated into a series of calls to the Fluent ESL. This right now it's an implementation detail. But if there were some interest in making it more, publicly available, that could be an option. So it's actually there, and we are actually using it. So
Thanks.
you're welcome.
And another one, we're using BPM for service orchestration. In our case, lots of services are long-running operations which do some heavy computing, let's say. And we need many times also a cancel support and timeout support that the process or rule will invoke the remote service to stop processing it, or if the user decides that it wants to cancel it, or if some timeout hits. Are you plan to integrate something like this in some built-in handler, or is just this like a custom code that you add on?
Yeah, I think definitely this is something in the works. There was also some plan for asynchronous, but in a different way than the JVPM 7 version of asynchronous, on a synchronous handler that will return a future, or there's definitely some space there. And especially when you call into external services, you want to have a way to time out and handle exceptions of that kind. So definitely stay tuned. And if you have specific requests, again, as Mario said, join us. Go to this website, kogito.key.org, where you will find links to the mailing list and to our chat channel. We're using Zulip, which is sort of like Slack, but it's a little better. And if you want, you can join us and chat with us. And yep.
Thanks.
Are there any other questions?
Okay, great. So I guess we can wrap this up.
Yep.
I don't know if